Hello guys, welcome to this lecture. This is a continuation of strings. So I think the previous video we have seen about character set, ASCII code, as well as about character array also. Separate character also we have seen, how to declare it, initialize it, all those things we have seen. Also about character array, the basics of character array also we have seen. Character array is similar to integer array, except that we will be referring to characters here. It means that numbers from 0 to 127 we will be referring to. And there in integer array, each and every block will be taking 4 byte or 2 byte according to the compiler. But here in character array, each and every block will be taking 1 byte of memory. So now we will be just continuing. Just I'll tell you one more thing. I told you that character array is what called as string, but generally in C what they does is that they call this as character array, this implementation. Then one more way of writing a collection of character is we can take a pointer variable. We can take a pointer variable, and what will happen in the pointer variable, what we can do is that now we can cluster all the characters. We can cluster all these characters and we can enclose it within a double, we can enclose it within double quotes. Now what will happen whenever I take a pointer, then the memory will be allocated in the heap, not in stack. So if you see, come to fifth line, this is allocated in stack and here the memory is allocated in heap. So if you see, there are two kinds of strings available. One is mutable, the other one is immutable. What is mutable and what is immutable? Mutable means editable, changeable, you can change it. Immutable means you cannot change it, you cannot edit it. Okay, so if you see this fifth line implementation, initialization, this is actually mutable one. Mutable means once you initialize it with certain characters, you'll be able to change it also. For example, you can just tell me the ch of 2. What is index 2? Index 2 is having C. So instead of C, I can just change it to, for example, capital R. Now similar thing. So now I will just print it and I'll just show you that changing the second index element is working fine. I'll just show you. So we will just initially go for compilation, then we will be just executing it. So compilation successful, execution. Yes, if you see AB, instead of C it is replaced with R and then comes D. So we are able to change a index value. We are able to change a index value. Now what I'll just do is that I'll just print one more string str. First of all, I'll just print and I'll show you whether it is also a valid string. Percentage yes, comma str, just str. Okay, so now we will check whether this is also working or not. Yes, this is also working. Now what I will do is similar to changing the second index into R, here also what I will do is str of 2. Let me try to change it. Str of 2 is equal to, I will just try to change it into same like R. Now I'll just go for compilation and then I'll just go for execution. Now if you see, the second part is not working. Second part is not printing. Why? What happened? We'll just go for this line by line execution, then you will understand what is happening when we are doing this str of 2 is equal to R. Okay, fine. Okay, successful. See, if you see, activation area for main is created. Now a 20 block is allocated here. So if I execute fifth line, we'll be assigning first 5 index with A, B, C, D, E and followed by all null characters. This is similar to actually arrays, normal arrays. In the normal integer array, what will happen? In the normal integer array, suppose if 20 memory block have been created and only 5 data is assigned, what will happen? All the remaining will be assigned to 0. That I have shown you already. Okay, So if we take 5 blocks and if we store only 2 elements, all the remaining 3 blocks will be automatically allocated to 0. When we do this declaration and initialization in the same line, this behavior will happen. The same behavior is happening here. I have assigned 20, but I have taken only 5 characters, so that except all 5 characters, all the remaining index are automatically by default assigned with null. Okay. Now coming to second line. If you see second line is a pointer. Still now memory is not allocated. You can able to see cannot access memory at address. Still now memory is not allocated. So let me execute it. Now if you see a memory key is allocated, and that is also corresponding to an entire string A, B, C, D, E. That address is entirely accessing A, B, C, D, E. Okay. Now seventh line, let me execute. Okay. If you see CH, second index is automatically changed to R. ASCII value is automatically changed to 82. Now eighth line will print it, and now comes ninth line. We will just check here. Ninth line, what will happen is you get a exception has occurred, segmentation fault. What is segmentation fault? Memory error. What is this memory error? What they have done while developing string is, whenever the memory is allocated in the heap, you will not be able to do any change in the index. You will not be able to do any change in the index. This is how developers have developed a C in terms of string. Okay, so what is happening? Error is occurring. So what happens suddenly when the segmentation fault is occurring? In few compiler, error will be thrown. In few compiler, what will happen is that the execution will stop. That's it. So the execution stopped here, but whatever happened before this are printed. But it stopped here, so the next line printing is not occurring because this is actually a wrong way of writing a code. Wrong way of writing a code. Okay, so hope you understand between what is mutable and immutable. Immutable means you will not be able to change any index specific values. Mutable means you will be able to change the index specific value. Yes, fine. So what is the next thing that we will be doing? The next thing we will be doing is how to find the length of the string. Okay, how to find the length of the string. So how to find the length? For example, let me declare a character variable called str with a size, for example, like static size 100. Let me take. Then we will just take scanf. You also can take it as a pointer, but let me take it as I'm just taking it as a array. Okay, so percentage yes, comma str. So now what could have happened is automatically, see, usually I told you to specify ampersand, but for string, with ampersand, without ampersand, both will work. Okay, with ampersand and without ampersand, because you know very well that whenever an array is declared, and simply when you just mention only the name of the array, then it refers to the first block address. So automatically str is referring to the first block address. There is no need of giving any one more ampersand because already it is referring to address. Okay, so there is no need of again giving a ampersand. Okay, so if you want also you can give, no issues will happen, but if you don't provide also no issues will happen here. Okay, fine. So now coming to the next thing that I have to tell you is that how to find the length. We know very well that scanf and especially percentage yes will automatically place a null character at the end of a string. Am I right or wrong? Percentage yes will automatically place a null character at the end of the string, and null character will determine the end. Okay, so what we can do is that, for example, I just can show you here. For example, we will just consider that these 5 blocks are allocated for a string character array, and what will happen is that we are storing values like for example, we can just take like Python. Okay, P T H O and N. Let us consider that we have taken totally 7 spaces we have taken so far, 7 spaces like this. So what percentage yes will do is that it will keep on reading. So once I just finish and enter, press enter, the next empty memory block will be filled with null character. So the in the background process in the memory, it will be stored like this. Okay, so this is referred to 0th index, this is referred to 1, 2, 3, 4, 5 and 6. Now what I can do is that I can take a variable called length and I can assign it to 0. So now len refers to the index of the very first element. It refers to the index of the very first element. So what I can do is that I can search for the null character. Wherever null character is there, I can just stop it and I can just count each and every character until I found a null character. So initially I take len of 0 and I go, when len is 0, I go to 0th index and check whether it is a null character. No, it is not a null character. So you can take this character in the as one character of the string. So you can count it and you can increment your len by 1 since the previous character is not a null character. Now after incrementing your len to 1, again check whether 1th index. Now go to 1, because when len is 0, you go to 0th index. When len is 1, go to 1th index and check whether this corresponding character is a null character or not. No. So this character is also included in the string. So increment your len by 2, because 2 characters that you have come across so far. Now since your len value is 2, go to 2nd index, the corresponding character is t. And now after checking whether this is tree, what is your job? Yes, it is not equal to null character, so increment your len by 3. Increment your len by 3. Now go to 3rd index. 3rd index is also not a null character, so increment your len by to 4. Increment your len to 4. Now 4th index is also not a null character, so increment your len to 5. Increment len to 5. Now go to 5th index. 5th index is also not a null character, so go increment your len to 6. Len to 6. Now go to 6th index. 6th index is having a null character, so stop the increment process, stop the whole process. Now if you see how many characters are here, 1, 2, 3, 4, 5, 6, 7 characters are there. Sorry, without null character there is totally 6 characters are there. That 6 is what referred by this len variable. Okay, so this is what the process that we are going to do to find the length of the string manually. So now what I will just tell you is that, let me first of all initially let me take a variable, integer variable called length, because integer length is going to be an integer value. 1, 2, length will not be a partial one, 1.5 length, 2.5 elements, 3.5 elements. We will not say 3.3 elements. We will not say like that. Okay, so and I can initialize that to 0 also. Now I need to do the repeated comparison process, so that I require a loop first of all. And what I need to do is that the corresponding len index character, should not be equal to null. So until it becomes null, I should keep on doing this process. So str of len, while str of len is not equal to single quote /0 null character, I keep on doing the process. So now here semicolon is missing, right? I can keep on doing this process. What I need to do first of all, if that particular len index, 0 index element character is not equal to null, first thing that you should do is that you should increment your len. That's it. No other job you're going to do. So first of all, what you do, take your len to 0, start checking whether the corresponding len index character is not equal to 0. If it is not equal to 0, then increment the length value. If it is equal to 0, then the condition becomes false and the while loop gets terminated and it comes to 11th line without incrementing your len. So finally I told you that the final process, len will point to the length. So printf, I'll just point to length. So what is the length? Percentage t comma len refers to the length of the string. So we can just go for compilation and just verify whether it is working properly or not. Compilation successful. So it's waiting for me to enter input. So what I will do is programming. How many characters are here? PROGRA, totally 6 plus 3 is 9 plus 2 is totally 11 characters are there. Yes, exactly, it is showing. Programming is having 11 characters and len is also 11 now. Okay, fine. So now I'll just do one more thing. Okay, I'll just do one more thing. I want to just find the length of C programming. How many characters C programming is having? Programming having 11, C 1 12, plus one space in between, including that, including space, we will be having 12 characters in place. So now we will just check it. Only one, only one, because I told you that percentage yes will stop reading once it finds some interruption like space and slash, a new line character. Since you have given a space here, it stops reading it. So how to overcome it? I want to read this entire thing until a new line is coming, until I enter. If I press enter, until I press enter, all the things should be read by the by scanf. What we can do, we have something called a scan set. We have something called a scan set. What is scan set? I'll just tell you. Between this percentage and s, you just open a bracket like this, square bracket. Inside the square bracket, what you do is make a cap operator and slash n. Cap operator slash n. What this will do, this is called a scan set. What scan set will do? So for example, if it just, I'll just save this and just I'll just compile this. So if I just compile it, and for example, if you just enter C, this character C which you entered will be taken and it will be done. What is cap operator? Cap operator refers to XOR operator, exclusive OR operator, bitwise operator. Hope you remember. What XOR gate will do? XOR gate means same bit equal to 0, opposite bit is equal to 1. So taking C and comparing it with slash n, new line character. I think C is having a different ASCII code and slash n is having a different ASCII code. So both will be definitely opposite bit. If both are opposite bit, what you will get? You will get true. So when this scan set is returning you true, this keeps on reading it. So now I enter space. Space is taken and it is XORed with the slash n. What it become? Both are different characters. Slash n is different ASCII code. Space is different ASCII code. So opposite bit. So true. So keeps on reading. So let me enter P. Keeps on reading. Programming keeps on reading. Now what I will do is I'll just press enter. When I press enter, what will happen? It is automatically converted to a slash n as escape sequence, so when I press enter, you receive slash n. That slash n is taken and XORed with the slash n. When slash n and slash n is XORed, you will get 0, because slash n both are same bit. So when same bit is XORed, then you get 0. So when this scan set is returning you false or 0, then you stop the reading process. So what this will do, until you give a slash n, this keeps on taking all the input in characters one after the other. So now we will check what should be the length here. Totally 11 for programming and one for space and one for the C. So totally 13. Yes, it is giving me 13 exactly. Yes, fine. So what is the next thing that we will be doing? Next thing is I'll be teaching you how to change the case, that is from uppercase to lowercase or from lowercase to uppercase. We'll see that. Okay, so see here, what I will just do is I'll just take few examples of characters and I'll just specify its corresponding ASCII code. Let me take A. Let me take A. Let me take B, C, D, E. Similarly, I will also take lowercase a, lowercase b, lowercase c, d, e. Okay, here I'll just left C. Okay, C, D, E. So what is the corresponding ASCII code of this cap? Uppercase A, 65, followed by 66, 67, 68, 69. Similarly, if you just see here, this is equal to 97, 98, 99, 100, 101. It goes on. So now, if a character A is given, a character A means 65. It is called a 65, right? Character A, 65, both are same. So if character A is given or 65 is given, if character A is given, then you have to convert it into a lower case called A. How to do that? So if A has to be, uppercase A has to be converted to lowercase a, then the corresponding ASCII code 65 has to be changed to 97. Am I right or wrong? Because in the memory level, if you see, number is only stored, not the character symbol. only the number is stored. So if you change the number, automatically the character also will be correspondingly changed. So 65 has to be converted to 97. So if I have to convert this uppercase b to smaller case b, lowercase b, then the 66 has to be converted to 98. So let me do 97 subtracted by 65. What I get? 97 subtracted by 65, I get 32. Okay, subtract 98 from 66, I get 32. Subtract 99 and 67, I get 32. Subtract 68 from 100, I get 32. Subtract 69 from 101, I get 32. So there is a common difference between the ASCII code of the uppercase character as well as the ASCII code of the lowercase character. So whenever you receive a character, uppercase character, and if you add 32 to the corresponding ASCII code, automatically it is converted to lowercase ASCII code. So if you want to convert a uppercase character to a lowercase character, then you add 32 to the character. It's not character, it refers to number, right? Okay, so when you add 32 to the character, automatically 32 is added to the ASCII code. So 65 will be converted to 97, 66 will be converted to 98, and so on. So I'll just show you a way. Okay, so what I will just do is that let me just take a character array. For example, let me take a character array called A, character array A, and let me assume welcome. This is a mutable one. Okay, because I need to change the case, so this is a mutable one. In immutable one, I will not be able to change the case because no changes can be occurred there. Okay, so character A is equal to welcome. Now I need to change the character, each and every character, to a lowercase. We know what to how to convert it to lowercase. Added with 32. What has to be added with 32? Each and every character. So how will you find the end actually? How will you find the end? By using the null character. So first of all, what we will do is we will just find what we'll do is we will just write a loop for accessing all the characters. So what we can do is that we can take an integer variable, integer I, and I'll just start from 0th index. I is equal to 0th index. We will start the process until when I can read. If my a of I, the character a of I, if it is not equal to null character, then I can keep on reading. Suppose if it is equal to null character, it is the end of the string, so you can stop the reading process. So here the condition looks a little bit different, right? So a of I not equal to null character, then comes a incrementation of I. Okay, fine. So this loop will now read each and every character of the array, character array. Now what I need to do, I need to change the case. So a of I need to be changed, but how to change it? I need to add 32 to the same character. I need to see w is there, I need to add 32 to w, and again I need to store it in the 0th index itself. So a of I is equal to a of I is plus 32. So take ith index character, add 32 and store it in the same ith index itself. So when a expression like this is given, how can I convert this? I can convert it into a compound assignment operator, because left side also I have the same operand, right side also same operand. So when I have such kind of situation, what I can do, I can remove one operand and I can take the symbol, and after symbol I can give equal to. This is compound assignment. We have already seen this, and why I prefer this is a little bit faster in terms of compiler process. Okay, fine. So now after doing all this thing, finally what I will do is that using percentage yes, let me print what is there in A. We will just check. Okay, so fine. So I'll just execute it and we will go for it. So can you able to see I have initialized welcome in uppercase, but here if you see all the characters are now in lowercase. So I have shown you how to convert the uppercase into lowercase. So we'll just stop the session here, and one more session we will continue from evening 6 o'clock. So where I'll be continuing from where I left. So we have seen uppercase to lowercase. We'll start from lowercase to uppercase. lowercase to uppercase. And we will see few problems in string, like counting number of vowels and consonants, validating a string, okay, counting words, swapping the cases of the string, then finding duplicate characters. So there are many thing, palindrome, there are many problems coming up. So which we will be handling it in the, which I'll be handling it in the evening session. Okay, so this is it for the session. Okay, so until then, this is bye bye.